The biggest challenge when creating this course was choosing a programming language. My first thought was to pick Swift. Swift is a modern programming language, and it has a straightforward syntax. The code written in Swift is easy to read and it's perfect for beginners, given all the tools Apple provide. Besides, it's open source. So why did I pick another programming language? The main reason is this: Swift is native to Apple. Therefore, it's perfect for those who own a Mac. You can even use it on Linux. However, there's no proper way to compile Swift on Windows yet. I also considered Java. Java's been around since 1995, but it's still trendy. The TIOB Programming Community Index ranked Java as the most popular programming language at the time of creating this course. Java is a cross-platform interpreted language. It was designed to run with the help of a Java virtual machine on any platform. That is, you could start programming in Java regardless if you are on a Mac, Linux, or a Windows system. Eventually, I decided to use Python. Here's why. Python is easy to pick up, and you can learn the basics of programming quickly. Let's have a look at an example written in Java. And here's the same code implemented using Python. Now, which version feels more natural? Python is one of the easiest programming languages out there. Python is a high-level programming language that has gained massive popularity among data scientists, AI, and machine learning researchers who want to get their job done quickly. I'm confident that Python will help fast-track your journey into the world of programming. Setting up Python on your computer. Let's begin by checking if Python 3 is installed and properly configured on your computer. I'll be using Python 3 in this course, so I recommend you install it too. If you're using macOS or Linux, you've probably got Python already installed on your system. You can check if you have Python 3 on your computer by opening a terminal window. On Windows, start the program called CMD. If you're on a Mac or a Linux system, launch the terminal program. You should get a window with a command line prompt. Next, type the following command in the terminal: Python 3 whitespace -- version. As you can see, I have the right version on my Mac. If you get some error message in the console, try typing Python whitespace -- version. If you still get an error, that means that Python is not installed on your system. I'll show you how to install Python 3 in a moment. Now, if you're a Mac user, then the chances are that you have the original 2.7 series of Python. 2.7 is the original, older version of Python. Although it's still getting bug fixes, it's not actively developed anymore. So if you don't have Python 3 on your computer, you should install it from the official website. Visit the python.org website in your favorite browser. Hover your mouse over the Downloads menu. The link in the drop-down defaults to the version of your operating system, but you can also select your platform manually. Download the latest version of the Python 3 release. After the download is ready, launch the installer and follow the instructions to complete your Python installation. Check if your installation succeeded by running the following command in the terminal: Python 3 whitespace -- version. Next, we're going to install and configure our development environment. Now that you have Python 3 installed on your machine, let's try it out. If you're on Windows, start the program called CMD. On a Mac or a Linux system, launch the terminal program. Next, type the following command in the terminal: Python 3. This command starts the interactive Python language shell, also known as Read Evaluate Print Loop, in short, REPL. A Read Evaluate Print Loop, also termed an interactive top-level or language shell, is a simple, interactive computer programming environment that takes single user inputs, that is, single expressions, evaluates them, and returns the result to the user. A program written in a REPL environment is executed piecewise. The Python shell executes the Python instructions we write. It reads the input entered by users, evaluates the code we typed, and prints the results so we can see the response. Then it loops back to the first step. Now let's do some basic math. We can add 2 or more numbers. Let's try, for example, 2 plus 2, or 2 plus 3 plus 5. We can also subtract numbers. 120 minus 3.14, or multiply them. 17 times 6. Divide. 64 divided by 8, or 129 divided by 98. We can even raise a number to a power. 5 squared, which should be 25, right? The Python shell can also evaluate multiple operations. Python follows the order of operations when evaluating math expressions. We can quit the shell anytime by typing exit. We'll talk about the parenthesis stuff later in the course. Now, we're back to our command line. What if I'd like to go back and work a bit on my code? If I open a new REPL, it will start everything from scratch. There's no way to go back and continue where we left off. REPL can be used to try out simple snippets of code. However, it's not the right solution if we want to edit or reuse our code. The interactive Python language shell, the REPL, can be used to quickly type and try out a couple of lines of code. However, there are a lot of things that the Python shell can't do for you. For example, you can't go back to the previous line if you want to change something quickly. There is no code completion or syntax highlighting, and you can't save your session to a file. Code completion is a feature that speeds up the process of writing code. As we start typing the code completion engine comes up with a list of potential candidates. Besides speeding up software development, code completion reduces the number of mistakes and typos, and we have to memorize fewer keywords, function names, and so on. Syntax highlighting improves the readability of our code by using different colors and fonts to highlight categories of terms. This in turn reduces the time required to figure out what the source code does. Code completion and syntax highlighting are available in text editors and integrated development environments, also known as IDEs. A code editor is a code-centric text editor that provides syntax highlighting and can save or open source files, but it won't execute your code lines. For example, Atom is such a code editor. IDEs are more powerful in that they let you execute and test the code you wrote. There are many IDEs that can work with Python. In this course, I'll be using Visual Studio Code. It's a versatile IDE that's available for Windows, macOS, and Linux. You can download the latest stable version for free from code.visualstudio.com. Visual Studio Code comes with a variety of useful plugins that will make our life easier when working with Python. After downloading VS Code, launch it and go to the Extensions panel. You can do that by clicking the View menu and choosing Extensions, or by clicking the Extensions icon. In the Extensions panel, type Python in the search box and install the one provided by Microsoft. This plugin comes with Python syntax highlighting, but it also lets us run and debug Python code from within the editor. Install the plugin and restart VS Code. Congrats! Now you're ready to start coding in Visual Studio Code.